In the 2022 September IT Paper 1, we had a very interesting question. In the first question, question number 1, usually question number 1 is not thought of as a difficult question, as usually reserved for any of the other questions, especially question 4. But this year, question 1.3, we got a bit of an interesting one, a bit of a spicy question. So it had to do with prime numbers, but it added another level of difficulty. We had to find prime factors. So it really meant that this question, was a big question for 21 marks, was split up into two halves, more or less. The first half is looking for prime numbers up until a certain input. And once we found and stored those prime numbers in an array, we then have to see if there are any combination of those prime numbers to equal our input that was given by the user. And this is the second part of the question. So I've already written out all the code, and you should have access to the memo. If you don't, it's on EC exams. So you have access to the code, but I will try to go through it line by line and explain how it is working. After this explanation, even if you, well, I'm hoping that you do understand what's going on, you should still try to do the code yourself. Write the code for the entire program on your own. Even if you're just remembering what you learned from this video, it's still better to actually do it yourself and make it more permanent in your memory. All right, so let's start. This program we have to accept an input from the user, which we get from set number, and we are storing that in input. So wherever you see input, that is the user's input. I think they used the number 16 in the question paper, which I do not have in front of me right now, but whatever, we're going to go with 16. So the user puts in the number 16, and now we have to find all the numbers from 1 up until 16, everything in between. We have to figure out which one of those numbers, or how many of them, are prime numbers. Now, how do we find or test if a number is a prime number in Delphi? So what we need to do is we need a loop, right? This section of code over here that I'm just highlighting now, this is the section of code that is going to test if a number is a factor, or sorry, is a prime number or not. We need to take the number, so let's say 16, right? We need to take 16 and mod it by a number from 1 until that number. We need to do that for all of them. That's why we have nested loops over here. So 16 mod 1, that means 16 divided by 1. And if we say mod, it means we're only looking at the remainders, not the dividend or the quotient. We're looking at the remainders. So 16 divided by 1, that gives you an answer of 16 with no remainders. And if that is true, we will increment a variable called iCountPrime. And now a number is a prime number when it only has 2 numbers that can divide into it without remainders. That is the number 1, always, and the number we're looking at itself. So let's start with an example, just so that we can have a clear understanding of what a prime number is. Let's look at the number, get out my notepad, 7. 7 is a prime number, but how do we know? If we say 7 mod 1, that equals 0. Because 7 divided by 1 gives you 7, but there's no remainders, right? Because it's a clean divide. All right, so that means that's one number. Then let's try 7 mod 2. And we're going to do this for every number up until 7. 7 divided by 2, 2, 4, 6. So the answer is 3 with a remainder of 1. 7 mod 3 equals 2 with the remainder of 1. 7 mod 4 equals 1 with a remainder of 3. 7 mod 5 equals 1 with a remainder of 2. And 7 mod 6 equals 1, because 6 goes into 7 once, but there's a remainder. And the last one is itself. 7 mod 7 equals 1 with no remainder. So if a number is prime, and you do this for all the numbers from 1 up until itself, so 1 until 7, you should only have 2 answers that equal 0. If you have less than 2 or more than 2, then that number is not a prime number. Okay, so we know 7 is definitely a prime number. There, we got it. Let's try another number though. Let's try 10. Don't worry, I'm not going to go through all 10 numbers. I'm just going to show you the ones. So we have 10 mod 1, and that equals 10 with a remainder of 0. Okay, so that's 1. Then we have 10 mod 2, and 10 divided by 2 gives you 5 with no remainders. 10 mod, what's the next one? 5. 10 divided by 5 gives you 2 with no remainders, and the last one that gives you no remainders is 10 mod 10, and that equals 0 as well. So I've skipped all the other numbers in between because I know that they will give remainders, okay, but I want to show you that even though we have 4 answers here that give us 0, that's not equal to 2. It has to equal 2. So 10 is not a prime number. Interesting as well, 1 can never be a prime number, even though 1 and itself, which is also 1, can divide into it and without any remainders. But if you say 1 mod 1, that gives you an answer of 1 with a remainder of 0, but you can't say 1 mod 1 again, because that's the same thing. Do you understand why 1 can't be a prime number? Because it has to be that 1 and itself can divide into it without any remainders. But if we do this, we only get one answer because we've already exhausted all the options, and we only have 1. So this is less than 2. And so that means 1 cannot be a prime number. So if you want a number to be prime, it has to give you 2 answers that equal 0 when you mod them together. All right, I think we understand what a prime number is now. If not, I think just try some Googling. Let's get into the code. So we're going to assume that our input is 16 for this example. So for I is equal to 1 to input, which means from 1 to 16. Because we have to check each number, because we're trying to find all the factors, we're trying to find all the prime numbers between 1 and our input, which is 16. So we have to loop through each one of them. And for each one, we need to test to see if it is a prime number. So we're going to set our counter over here, our I count prime to 0. And now with this inside loop, we are going to test from 1 until I, which is the number that we are on between 1 and 16, to see if it is a prime number or not. So I starts at 1. We have k, and I is equal to 1. So I'm going to put a comment there. That means k is only going to loop from 1 to 1, which means it's one loop. So even if we say 1 mod 1, and that gives us a remainder of 0, I count prime will only ever be incremented once because it's only one loop. That means I count prime will never equal 2. All right, so 1 is not a prime number. Let's try 2. So I is now 2. Okay. We reset our I count prime back to 0 because we started a new number. And now we are saying for k is equal to 1 to 2, because I is now 2. So we're going to have 2 loops over here. All right. So if I, which is 2, mod k, which is starting at 1, so 2 mod 1, 2 divided by 1 gives us an answer of 2 with 0 remainders. That means this is going to increment I count prime to 1. So I count prime is now 1. Right, we go back to our loop again. K becomes 2. So now we have 2 mod 2. So 2 divided by 2 gives us an answer of 1 with no remainders. That means the if statement is true again. And we increment I count prime, which now becomes 2. All right, now the loop is finished because there was only 2 loops. We move down over here where we're checking to see what is I count prime. Okay, remember this is still in the first loop. It must happen for every number. So I count prime is indeed equal to 2. That means we're going to add this number to our array for storage because it is a prime number. So we're incrementing our array counter, which started at 0. It now becomes 1. So in element number 1 of ARR prime factor, we're going to add I, which is 2. Let's represent that visually. Here we have our array. I've just added a couple of boxes from it, and we're going to add our numbers into it. So inside I count array, which is now 1, which means element number 1, we're going to add the number 2. That is our first prime number. Okay, now we move up, and I becomes 3. So let's change that to 3. We reset I count prime to 0 because again we're starting with a new number now, and k is equal to 1 to I is 3, so 1 to 3. So this is going to be 3 loops. All right, let's test. So if I, which is 3, mod k, which is starting at 1 again, so 3 mod 1, 3 divided by 1 gives us 3 with no remainders. So that means we're going to increment I count prime, which is now 1. Right, k becomes 2, so 3 mod 2. 3 divided by 2 gives you 1, but there's also a remainder of 1. So this is not true. That means we skip this and we do not increment I count prime. It stays at 1. K then becomes 3. So 3 mod 3. 3 divided by 3 is 1 with no remainders. So this is true, and we can increment I count prime again. It becomes 2, and we're done with that loop now. Okay, we've done all 3 loops. We go down, we see, is I count prime equal to 2? Yes. Therefore, we increment I count array, which now becomes, let me keep track of this, it becomes 2. And in box number 2, element number 2, we're going to add I, which is 3. So let's represent that. Here is I count array 2, which is box number 2, and we're going to add the number 3. There's our second prime number. All right, I'm just going to try one that isn't a prime number, which happens to be 4. So I becomes 4. There we go. We're now looping k from 1 to 4, so there'll be 4 loops. All right, 4 mod 1, because k restarts again at 1. So 4 mod 1. 4 divided by 1 gives me 4 with no remainders. All right, so that means we're going to increment I count prime from 0 to 1. Excellent. Now k becomes 2. 4 divided by 2. That gives me 2 with no remainders. Excellent. So we increment this again, and it becomes 2. Now k becomes 3. So 4 divided by 3, that gives me an answer of 1 with 1 remainder. So this is now not true. We do not increment I count prime. It stays 2. K then becomes 4. So we say 4 mod 4. 4 divided by 4 gives me 1 with no remainders. So this is true. We increment I count prime, and it becomes 3. All right, the loop is finished. That was all 4 loops. And we now check to see what I count prime is. I count prime is not equal to 2. It's equal to 3, which means it's not a prime number, which means this doesn't happen, which means we will not be adding 4 into our array. It is not a prime number. Okay, now I'm going to skip forward. The same logic applies, and you can write it out on a piece of paper if you want to go through all 16 numbers. Go ahead. But I'm going to skip ahead and I'm going to add the rest of the prime numbers here. So 5 is the next one. Then we have 7. Then we have 11. Then we have 13. And because we are stopping at 16, we're not going past the number 16. This is it. There are no other prime numbers. 17 is a prime number, but that's past 16. Okay, we're not looking at anything past 16. Our input was up until 16 only. So here you have it, ladies and gentlemen. Our array has only 6 boxes. I count array is equal to 6, and this is where we stop, right? We do not use the rest of the array. Okay, that is the first part of the question done. Now, if they ever ask you again, find all the prime numbers between 1 and 100, you can use this exact section of code here and it will do that for you. Doesn't matter how many numbers you're looking at, whether I input is 16 or whether I input is 100, it doesn't matter. It will scale up and it will find all the prime numbers between those two numbers for you. Okay, that's done. Perfect. Now we move on to the second section. It's in the same event, same button. But now we are going to look at our array that we have here, and we're going to try and, this is where the factor part comes in, right? We just did the prime part, now we're doing the factor part. So we're trying to see, is there any combination, if we add two numbers at a time, is there any combination that will equal our input, our I input, which was 16? So if I take 2 and I add it to 3, will I get 16? No, it'll give me 5. So that's not 2. 2 and 3 are not prime factors of 16. We don't want them. What about 2 and 5? No, that gives us 7. So they are not prime factors of 16. What about 2 and 13? No, that gives us 15. Again, so 2 and 13 in this case are not prime factors of 16. Okay, that combination is not prime factors of 16. So we need to set up a structure of loops to loop through through this array and add up two numbers at a time in all possible combinations until we find all the combinations that will equal a sum of 16 when you add them up together. All right, so just thinking about it now, we'll need one loop to go through all the numbers. Then we'll need another loop to get a second input to add the two together to see if it equals to 16. And this is how we do it. So we have the first loop, okay? This is now a new set of loops, got nothing to do with the stuff that we just did in the top half. We're looping from 1 to I count array. Now remember, I count array is keeping track of the number of boxes or the number of elements that we've used in our array, which is 6. So I'm actually going to put 6 here because in this example, it's equal to 6. So we're looping from 1 to 6 minus 1. What does that mean? That means we're actually looping from 1 to 5, which means that we're ignoring the last box. We're only looping from 1 to 5 in the outside loop. Okay, we're going to see why in a second. Okay, and we capture that number in inum1 for later. Then we have an inside loop which is starting from I. So wherever I is, then it is going up until I count array. So it's going to the end of the array. Now I want to show this to you visually because I think that is the easiest way to understand what's going on. So I have, let me get a red color here. So our first one, which is I, I is going from 1 to I count array minus 1. So it's going from here to here, and it's leaving out the last one. And then we have k. There's k, and k is going from I. So for the first part, the first set of loops, it'll start at 1 as well, and then it goes all the way until the end, until I count array. So it's also starting over here, and it's going all the way until the end. So even though it's an inside loop, it starts out bigger than the top loop. But anyways, we start at the beginning. So I equals 1. So that is ARR prime factor element number 1, which is 2. And K is equal, we're starting at 1, and that is also equal to 2. So if we add these two together now, which is what's happening over here, if I num1 and I num2 equals I input, remember, I input is 16. So if 2 plus 2 equals 16, it doesn't. It equals 4. So we don't want it. Now we're busy with the inside loop, so the inside loop becomes 2, which means it's referring to 3. So if I plus k, if 2 plus 3 equals 16, it doesn't. That moves to 3, which represents 5. So if 2 plus 5, nope, only gives you 7. 4, 2 plus 7, nope, that gives you 9. 5, which is 11. 2 plus 11, that gives you 13, still not 16. What about the last one in K? So this represents 13. So 2 plus 13, still not 16, gives you 15. So there is no possible combination that includes 2 that will ever get you to 16 there. So 2, we can literally scratch that off. 2 is never going to be a prime factor of 16. We tried every single possible combination with the number 2, even itself, 2 plus 2, and it didn't give us 16. All right, so what happens now is this goes back to the top, and I then becomes 2. All right, so box number 2, I'm going to erase K because I want to make K again. I want to, because remember, K is the inside loop, so it starts from 1 or from I every single time the outside loop starts again. Yeah, let's get a different color this time. All right, so K is, I is now 2, and K starts at I. So K will now be starting at 2, and it will still go until the end as normal. So K starts at 2 this time. So we're starting at 3 plus 3. I plus k, 3 plus 3, that gives us 6, not 16. So this becomes 3, which represents 5. So 3 plus 5, that gives us 8. Still not what we're looking for. Go until 4. This is 7 plus 3, that gives us 10. Still not what we're looking for. Then this goes until 5. We have now 11 plus 3, that gives us 14. Close, but not what we're looking for. K then ends at 6, which represents 13. If we take 3 and we add it to 13, let's write that down. 3 plus 13, that does give us 16. All right, so we found our first combination of prime factors that gives us 16, which means that 3 and 13 are going to be prime factors of 16. All right, and this is what the whole question was trying to do. It was trying to get us to do. This is pretty much the last part. The only thing that we need to do now is, here we have it. We say I num1 plus I num2. If it is equal to I input, which is 16, so we can pretend that I num1 is 3 and I num2 is 13. It equals 16. Then what do we have to do? We have to display those two numbers, and we're going to let our little flag know that we did find at least one combination. Let's try that out. All right, so here in question 3, I'm going to say 16 as my input, and I'm going to click on the button, and there we have 3 plus 13. That's our first combination, right? Now, obviously, the loops are going to carry on right until the end, and we do have another combination over here, which is 5 plus 11. So we have two combinations. So 3, 5, 13, and 11 are prime factors of 16. And there you go, ladies and gentlemen. That's question 1.3. I must say it was a little bit tricky. The first part, I'm sure most of us knew how to do, and even if we didn't, we would have been able to figure it out. But the second part, it just added that second level on top. What I suggest you do now is you look at this code, you make sure that you understand what's going on, and then you do the program yourself from scratch without looking. Do as much as you can. If you get stuck, go back to the code, look at the code. And even if you feel like you understand it 100% now, please do it yourself. Write out the code. Even if you feel like you're writing out something that you already know, just write it out once until you can write out all the code on your own while remembering what to do. And that's going to make sure that you understand that process. If you don't have data files, then write it out on a piece of paper. It's the same thing, right? It's what we did at university. We wrote our code out on paper. All right, and that'll be it.